This is Electric Universe Eyes, and today I have my neodymium cube magnet that's going to be hooked up to the positive side of the rectifier bridge, and the negative is just attached to a nail. I've got this placed in a porcelain soap holder, and I'm merely going to pour some distilled water into this and then turn on the power and see what happens. Now, before I do anything, I just want to say, don't play with electricity. It's really dumb. You will die if you do the wrong thing. It's not for playing around with at home. All right, there's just a little bit. And let me step back and let's turn on the variac. All right, I think I'm going to pause this now because I can't see anything. And I'm thinking of how my wife always makes somatics, and she puts charcoal or something into the water to reflect the light off of the vibrations. So I think I'm gonna take some synthetic black iron oxide. I'm gonna put right in between this and see if the charge moves it. How about that? Okay, what do you think? Do you think it's going to have electromagnetic somatics, or is this merely just going to be attracted in the water to this neodymium magnet? I think it will. I'm going to place this closer to where the negative electrode is. So let's put it... Oh, look, and you already see it being attracted over there to that magnet through the water. So you know what? I'm going to just... Let's put it all over here on the negative side. And then now let's turn it on and see what happens. Okay, I'm becoming impatient. I think what I'll do is, let's arc from the negative electrode. I'm gonna grab Robot Man and hook him up real quick. He's hooked up, so he is now the negative electrode. So I can't touch any of this little robot guy here, but I can see down in there kind of. Okay, there we go. It is just above. There's just a slight gap, if you can see it. Oh, can I see it? Can I even see it? It's real difficult to see, but I don't want to get too close to this thing because it'll get me. So I'm just going to stand back. Pretty cool. I'll turn the lights on. keep seeing an arm off to like the top left. And it's kind of reminds me of a sun filament. Well, it's definitely moving in a counterclockwise rotation, similar to the hurricane. I should have set up my microscope. Maybe I'll come back and try it again. Let's see if I could do this. I am going to, let's dial back the variac and reduce the power. That's cool. I can't tell how far down I've got it probably halfway cut. My variac goes from 0 to 130. See, now it's reaching towards the outer edges where that iron oxide is. At least that's what it seems like. Keep turning it down more. That's where I lost it. All right, I'm at about 25 output. Out of 0 to 130 volt range, I'm at 25 volts. Again, that's what's going into my transformer. So I don't know the actual calculations. I'll have to check that out for you. But so at about 25 volts, let's see. I gotta get back up to 50 now for it to re-engage. It's a cool little arc too. Turn it all the way back up. That's all the way full on. And reduce it again. Fairly fast. And at about 25 volts is where it loses it. But I still hear it. See if I can go all the way down to 0 and bring it back up. I still hear it. Look at that. And I see the water move. Huh. So I still can't hear any or see anything, but I can hear. Maybe you can if you listen closely. Turning it up at about 35 volts. So look, you can see it vibrating. Oh, and little bitty arcs are coming off. Wait. Oh, no. No, that was just the reflection. That's just the reflection. That's cymatics right now through. I don't see a physical arc. No, I'm lying. I see a tip of an arc at the very end of the nail. So I need to get a camera mount. I'm balancing my phone on something. I just don't want to get too close. And I should have set up my freaking microscope. My bad. I was gonna do a completely different experiment, and then I was looking for a new tray to use, and I decided to just do this. But I'm glad I did. This is kind of interesting. And I want to thank everybody that helped me get a bigger transformer and a variac and diodes. Man, you guys are awesome. So I just got another donation today, and I'm really happy about that. Thank you very much. Keep buying better gear. I need to buy some really awesome cameras. All right, here's what I want to do now. I want to see what happens when I reverse this and put the positive on this electrode and the negative on this electrode. Will I see anything different happen? Oh, look at that. That's cool. I think that's just still the magnet is pulling all of that iron oxide in as the water levels are changing. Oh, but you know what? I see the water vibrating. Oh, that's cool. It's kind of pulsing around there. Let's see if I can get the reflection. There it is. Yeah. And that is helping that flow, I think. I'll play with this a little bit more, and then I'll switch it around. Let's go. Huh. All those bubbles. It's interesting. Look how it just creates all those little oxygen bubbles. Just separating out the hydrogen and the oxygen. That's cool. All right, let's turn it off. Now I'm switching the poles. All right, I've switched poles, so now they're reversed. What we're looking at is the positive pole. And now let's boost up the power. Doesn't stop the magnet from working, that's for sure. And it still looks like it's going in a counterclockwise rotation. Let's turn the power down. The arc seems a lot more focused, even at low power. Oh, look at that, that's cool. And I see a really small, itty bitty baby arc right at the tip. And it's still moving that water around. I'm right about between 30 and 35 volts. Sorry, I want to say, I need to correct this. It's not 30 volts. It's 30 volts output to the transformer, and the transformer is a 10,000 volt output transformer. So I'm only giving 10,000 volts 30 to 35%. So it's really more like 3,000 volts. This would be like using my 3,000 volt transformer right now. That's full power. And it's going to be fun getting that off the magnet too. It's all good. I didn't need to use that, I just wanted to try it. It's the same magnet I used when I made my very first crater on a clay ball. You know what? Let's do this. Let's kill this. Just for kicks, I happen to have a clay ball from that same time. Let's put that in there. Just to see what happens. I don't think anything will happen really, but I got a better idea. Let's do this. I'm gonna put that clay ball over in between that. All right, here we go. I'm either gonna be done with this real quick or something awesome is gonna happen. So I set this clay ball, which is completely dry. It's terracotta modeling clay. Completely dry in this water on top of this iron oxide, sitting in water. So let's see if anything cool happens or no. Wow, that was crazy.
Crazy. crazy.
Okay. Look at that. Completely dry terracotta clay. Hey, look. That looks just like a lot of features people say is wind or water erosion. Hey, look what that did back there too. That's pretty cool. That was awesome. Let's see if it'll keep going. Let's turn it back on. All right. I bet if I let it sit there and soak up the water, it would do something, but since I am impatient, I'm gonna just move the electrode down some to make it closer. Hey, look at that crater it blew out of the side. Neat. Oh, and there's like, what? Hold on. Hold on. Hold your horses there. Look at all those little bitty, craters in there. And those little holes that popped out, man. I'm gonna have to do some studying of that after the fact. Okay, let's try this again. Are you ready? Because I am. That was cool. Well, why isn't it? That's weird. Get in there, I think it's okay. Yeah, it's just discharging down to the water. But it doesn't want to let go of the top of that clay ball. But it's reaching for the water. I like that a lot. See what happens. It's got to get real hot and I'm going to try turning the input power down on the transformer. Oh, that's cool. Let's go down a little lower. That's awesome. Turn it back up a little bit. Well, a lot. Oh, I lost it. All right, let's try to reset at full power. All right, let's go a little closer. All right, that should be good. Ready? Set. Oh, man, come on. Okay, here's what I got. Remember this guy? Yes. I'm gonna dab some water right here. Oh, that's cool. Whoa. Get it, magnet. All right, we're going to just dab some of that water on the top of this ball so that it becomes a little bit more conductive. And I bet it's going to explode all that wet out, and it's gonna crater big on that side. That's what I think. So let's try now to, let's paint this side. Oh, it's hot. Look at that, it's so hot. Oh my goodness. All right, so that side's all wet. Let's turn it on even while it's bubbling. Wow. Man, I would not want that on my face or my skin. That would be insane. Oh my gosh. Okay, look. Look, the whole top end is a crater, but that's just, you saw it. I mean, it's amazing. I love it. Well, pretty cool. Let's, all right, I'm almost done with this, but let's do it again. I'm gonna let it soak in this time, actually. Let it go all throughout the ball. Look, and it's still so hot. It's just soaking it up. Here, let's get some of this iron oxide in the mix here. Yeah, put some of that iron oxide on there. Cool. I think this is gonna be nice. Are you ready? All right, here we go. Oh, you see what was starting to come out of the top though? Look at that, right there. Look at that. It's extracting some mineral. I like that. Well, let's just, try again. Got that stuff all over my hand. crazy stuff right here. Oh man, okay, well, certainly was fun. I think that's what I've got on this one. On the next one, I'm going to try to recreate land and ocean with an electrode that goes over both parts and then see what happens. I just noticed also, you know, it's probably because that one's over here and that's over here, but I found this little S yin-yang shape to remain kind of interesting. But you know, I'm gonna blame my brush. I don't know. Hey, that's what I got for you today. That was fun. See you next time.